All right, great. Welcome all. Thank you guys for joining BigRep's blade training. Maggie's coming to us from New York today and is going to walk us through kind of a basic blade training. We set out a few things she's going to do, but have Blade open. If you don't have it, you can go to bigrep.com/blade and download it. That would be an important step as well before we start here. But you can have that open and you can follow along as Maggie goes through some of the steps that she's doing. And I will let her take it from here. Go for it, Maggie.
Good morning, everyone. Thanks for joining us. So yeah, I'm just going to start. Like Abby said, I think you got sent out a list of really just some basic stuff covering blade, and then we'll see if we have extra time. We can cover some more stuff, do some questions, things like that. So I'm assuming a lot of you are probably already used blade, but I'm not sure. So I'm going to start with the basic.
We're going to ask that. Here, let's do that.
Okay.
All right, here's a poll quick. Those of you on the call, are you currently using blade? This will give Maggie a good idea. It's Monday, have to forgive me. All right, so right now you got about 70, almost 80% that are using it and 4 are not.
Okay.
I'll give you a couple more seconds, but I think that's probably, yeah, that's almost everybody. So you've got, yes, 15
Great.
people
so
on the call are using it. Yeah.
Okay, perfect. Well, then you'll probably know some of the stuff I'm going to cover already, but we'll just start from the basics. So when you have Blade open, I'm just going to go over the basic toolbar on the top here, bringing in files. As you know, you need a clean STL to bring into Blade. You can hit open here, you can click and drag. I'm going to click and drag the first file that's in that folder that you all received, which is an intake manifold. So as you know, there is an auto orientation within Blade, which is going to orient this part to the best of its ability to, avoid a lot of support structure, have the cleanest, fastest print. A lot of times you might want to then change what that orientation does depending on your part, and if you want a certain surface to look a different way. If you need a certain surface to have a better finish, you don't want support somewhere, obviously you're able to manipulate that orientation. Over here is just where all your printers are located. So as you know, within Blade, you can just have one screen and you can have all of the available BigRep printers in there. And then you can just kind of toggle through whichever one you own, whichever one you're slicing for. Everything from the Studio to the Pro to the One. Stay with the Studio G2 for now, actually. And then next we have our 2 extruders. So all of our machines are dual extrusion, as you know, T0, T1. You must have them enabled to slice for them. And then down here, we actually have all of our available materials. So this includes everything that BigRep sells and offers within our material catalog. If a certain material doesn't work with your machine or with the nozzle, Blade will tell you that. So you will get an error. It'll come up saying it's not able to slice it or it's not compatible. So for now, I'm going to slice this part. I'm going to go with high temp CF, one of our new materials. And then I'm going to use the dual extruder with our BVOH for our support. And as you see here, so with the G2, you only have the option for the 0.6 nozzle, but with the other machines, this is also where you would, if we switch back to the Pro here, this is where you would change between which extruder you're using or which size hot end you're using. And then if you want, single extrusion, if you're not doing dual extrusion, you can just disable the second printer. As you see now that I disabled that T1 extruder, the dual extrusion option has now been erased and you don't see the prime tower anymore. But since I want to slice for dual extrusion, I'm going to select that again. And then the last bit is actually, where all sort of the brains and all the settings are located. I'm not going to get in depth into every single one of them today. Some of these will come up in the advanced training. Some are just not necessary to get into, as you're not really going to be playing around with them, but I'm going to touch upon a few things this morning. So the first thing is, the default, oops, sorry about that. That is my cat in the background making an appearance. The first thing is the default layer height. So what you're going to select is, the layer height you want. So for this specific combination, high temp CF and BVOH, currently right now, we're just offering a 0.3 layer height. What you do see here is the default versus visual. So default is going to be a slightly faster print. As it's titled, it's our default settings. The visual is going to be something that's going to be a bit slower, but is going to give you a slightly better print outcome. So generally the differences, major differences between default and visual are the speeds, and mostly the speeds located on the outer surface print area. So, if you toggle between the two and you look under the speed, you'll see that those things change. So generally for the visual, I think it prints at a slower percentage for that outer loop and for top surfaces. So generally anything that you're going to see on your print is going to print a bit slower with that visual setting. So it's really up to you what you're trying to achieve and how quick you're trying to achieve it. So for now, since we have the 0.3, I'm going to stick with the default for this morning. And as you can see here, this window keeps popping up, and this is something you might have encountered when you're using Blade. A lot of times when you make changes to our settings, those are saved within your window, within your Blade window here. But if you then go and select, you want a different layer height, if you want a different material, it's always going to come up whether it wants you to keep the changes that you've made or to discard them. So it's actually quite helpful because a lot of times you'll forget that you've made changes in there at some point. You'll bring in a new STL in the same window, and then this will actually pop up. So it'll allow you to say, yes, let's discard all my changes I've made because this is a new file, a new settings. Or it might, be a new STL, but within the same category, and you want to keep those specific changes that you've made. So for now, I'm going to hit discard because I was working on something before this call and I don't want it to carry over. So next, I'm actually going to touch upon the stuff on the left side here. This obviously came in small. A lot of times if you're working in inches and you bring models in, as you know, all of our machines and Blade are all metric systems, so they're all in millimeters. So I'm actually going to scale this up. Oh, sorry. So here on the left-hand side, you have your basic tools in terms of, movement, scaling, mirroring, things like that. So I'm actually going to, use some of these tools. I'm going to do some rotating here. This is also where, if you want to orient your part differently, these are sort of the tools that you would use. So also over here, so we have the orientation tool, which allows you to just manually flip this around into 3 different axes. Right now I have it on snap, so you'll see that it snaps every 5 degrees. You can obviously turn that off if you don't want it to snap. The other really helpful tool is this one. So it allows you to select a surface. So say for some odd reason, I want to print it on this surface. So I would select this tool, hit that surface, and it actually places it flat on that surface. Clearly, you wouldn't want to print in this orientation for this particular part, because obviously there's a lot of support now. So I'm going to just use that tool again and flip it back around. But a very helpful tool to help you orient the part upon a certain surface. Then, as you see here, we have what I had used, our scaling. This part wasn't actually in inches, it was just a bit small, so I just scaled it up 500%. So that we can have, a look at what a big print would take this machine. We then have the move tool, so you can move this around, move it left and right, move it up and down. Obviously, you want it to be on the bed. And then as you see in this preview here, everything that's red is essentially a cantilever or a bridge, or something that's touching the print bed. So anywhere that's red is actually going to generate support. So it sort of helps allow you to see where support is going to be generated, what surfaces the support are going to touch. As you can see here, there's not much, but when I had it flipped the other way, there's a lot of red surfaces. So it also allows you to see, do I have this oriented properly for, you know, minimal support and maximal print outcome. And then over here, we have a mirror tool. So if you want to mirror this part, you can do so. You can mirror it again in all in X, Y, and Z. And then the last three here are a little bit more complicated. I'm not going to go too in deep with these as they're actually part of the advanced training, but I'll touch upon them quickly. So here we have our support block tool. So essentially, if there's any areas where it is generating support, but you want to, you know, risk it and say it's okay if there's a little bit of sagging, I don't want support touching my model. Or, you know, if you have, it's sort of known with our machines that, you know, circular or like a tube element prints actually okay without support, but Blade is going to generate it because it's over a 45-degree angle. So what you can do is you can, you know, hit block support. So say like this area, for example, we actually don't need support within this small area. Sometimes support just causes more trouble. So an element like this will print fine without it. So what I'm going to do is just have that support blocker selected. Click on the element, it actually inserts a small little like cube volume there. That's the standard shape. And then I'm actually just going to scale it up a little bit and then move it. So it actually, you want that whole red area to be encapsulated by that form. So I'm going to make sure that it's covering that whole area. And there you go. So now no support will be generated there. I'm going to do it also for this one. So you have to have your STL selected as well before, and then you hit it like so. I'm going to scale it up a little bit and move it back. I'm not going to go through and do all of these, but essentially that's what you would do for this part. And then over here, we actually have a manual support, a way to add support essentially. So if there's areas where support is not being generated, usually this is used, like say you have a part that, which maybe actually we'll probably look at with the second STL or third STL I'm going to show you, but a part that's thin, you're worried about shaking as the print moves up, you want to add some additional support to sort of anchor that print to the print bed. That's how you would do it. So it's a similar thing to the support blocker. Again, you get just a cube shaped volume. And then you can scale it and move it around. The one difference that you'll know between the two is that support remover is just a solid gray, transparent gray, and then the support addition has stripes. So that's the way you can determine which is which if you have added a bunch to your model and then are unsure. So for this particular model, we don't need this, but I just want to show it quickly, so I'll delete that now. And then I'm going to go back over here. And what I'm going to do is I'm going to make sure that, because I want to use dual extrusion for this print, I want to use the BVOH for the support. So I'm going to make sure that my support extruder is indeed the T1, which is, my extruder that has the BVOH. And then I'm actually not going to mess with anything else over here for this particular print. So I'm going to close this out, and then I'm just going to hit slice.
Oh, while that's slicing, if you guys have any questions, you can feel free to chat those in, or if you want to just unmute yourself and you have a specific question about what Maggie's working on at that time, feel free to unmute yourself and ask. Want to make it feel like we're really in person, so feel like you can ask a question at any point here, if you have some.
Hey, Maggie, it's Andrew from Design Point.
Hi, Andrew, how are you?
Doing well, thanks for doing this today. Just a quick thing, I just missed really quickly how you go from, I saw the support blocker or the support adder. How do you do one or the other? I missed the difference. I mean, I understand what they are and how they work, just not how you click on one versus the other, sorry.
Sure, no, that's okay. Let me cancel out. This is actually taking really long, so I'm going to scale it down a little bit anyway, so that the slicing is a little bit quicker. Basically what you do is, they're here. So this is the support blocker. down here. So yeah, click on it, click on your part, and then you can scale it up. And the support blocker, like I said, is just a transparent gray. And then the addition of the support is just right above it. So it's this square right here.
Great, that's what I missed. Thank you.
Yeah, of course. So I'm just going to delete this one. And then let's hit slice again. Hopefully this moves a little bit quicker now that I made it smaller. And then, yeah, so the next thing I will talk about once this slices is also saving files. So really important to save your project file as well as saving the G-code. As I'm sure a lot of you know or have done, when you only save the G-code, you're not actually able to open it back up in Blade as like a raw file like this and make adjustments, because Blade always will revert back to the last thing you were working on. So really important to save, side by side that project file along with the G-code in case, of course, the G-code doesn't work out, you want to make changes, you'll have that initial file to work on. And I'll show you how to do that now. I just wanted to mention that while it was slicing. So now we're still in prepare mode, but we do see, that it is sliced, so we can swap over to pre. Now it's just processing the layers, so it allows us to see, how it's going to look when it prints. And then over here, if you have actually your computer on the same network and directly hooked, and your machine is also hooked up via Ethernet, you actually will have an option to, save file directly to your machine. There's also, if you have a USB hooked up to your computer, there will also be an option here as well to save to USB. Since I don't have either of those currently, it's just giving me the save to file option, which you just then save to your desktop and copy over to your USB. But just so you know, if you do have your USB plugged in, you can save directly to that. So here now we have the preview. So obviously this print does take quite a long time. I think when I do it not dual extrusion, it's under a day, but I do have it at a pretty high resolution. And because, we're using dual extrusion, there's a lot of movement. BVOH, if you have experienced it, does print quite slow. But, I chose to do it this way because I wanted this surface finish to look impeccable. And BVOH is the best way to achieve that, as it can print, right up against your part. You can then soak it in water, remove that support, and you'll have a really, really clean finish. So as you can see here, a little bit, it seems that I didn't push my support blocker in deep enough. So it is generating a little support within this hole. But as you can see here in this other area that I turned the support off, you can see that support is not being generated anymore like it is in the one below. So it's really helpful to have a look at your preview, think about the changes that you've made, make sure they're all translated properly. And then, yeah, so the great bit about Blade, and part of the reason we made it, instead of using third-party software, was to get, a really clear, really on-point amount of hours that the print is going to take. So there were a lot of issues before using third-party software where, it was under, saying, it was going to take a lot less time than it actually was. And it's really important, obviously, for all of you, when you slice a part, to understand, okay, this is going to take 2 hours, it'll be ready by this day. So Blade does give you a really accurate time estimation. It also breaks down the material. So if you hover over this eye, it tells you, the amount of high temp CF that I'm using versus the amount also of BVOH. So it allows you to really price it out as well and understand the costs and, prep your machine for printing. So knowing how much BVOH you need on that spool and how much high temp you need. It also breaks down the time estimation even further. So I don't know if a lot of you have looked at this, but if you're really trying to optimize your print, it tells you, how long the infill takes, how long the prime tower takes, how long the retractions take, et cetera, et cetera. So, if you see that your support is taking like 40% of your time, you might want to go back, think about the orientation, think about how to delete some of that support. And then, so yeah, getting to that saving files aspect. So save to file, this is going to save your G-code file. So, you know, as you see here, G-code file, I'm going to hit save. But like I said, really important to save also your project file. So to do that, you have to go to File, Save Project. And then it says, you know, summary of your project. It gives you here. You can hit save. And then as you can see now, you have a 3MF file. So saving these under the same name is also very helpful. You know which ones go with which, in case you do have to make changes to that G-code.
Margaret, can you hear me?
Are there any other questions? Because if not, I'm probably going to switch to a different machine, different STL, and hit upon some other topics.
Yes, sure. I have a question. Felix here.
I think someone's talking, but I can't.
Excuse me.
I can't really hear.
Can you hear me now?
Yeah. Yep. You're a little
Okay.
quiet, but I can hear you.
Yeah. Unfortunately. Yeah, my question is regarding the connection of the machine over the network. Is there a setting here in Blade where I can easily change IP address and stuff like this, or how is it done over the Ethernet?
It wouldn't be, you wouldn't change the IP in Blade. I don't have a lot of experience changing IP addresses. I just know that if you go to the screen on, you know, the GUI on your machine, and you go to the top dots in the right-hand corner, it'll give you that IP address, and then you would type it into an internet browser. In terms of Blade, you just have to be on the same network, your laptop, as your machine is on. So, you know, if it's your Ethernet like Wi-Fi network at your office, you should then be able to save directly to your machine. But if you do run into some issues, a lot of times it's an IT or firewall issue, which unfortunately I'm not able to help out with. But if you have further questions about that, we can follow up, and I can, you know, inquire with our software team.
Yeah, sure. Would be helpful. Just interesting to know where to take care
Sure.
of.
Yeah, no problem. Okay, so I'm going to go back to prepare. I'm going to clear build plate. I'm actually going to switch now, do a print on the one machine. So I'm going to go up here, switch my printer. As you can see, the whole layout changes. We now have a lot more options in terms of layer heights. And then as you can see here, we now have, you know, the option for the 0.6, 1, and 2 millimeter. So I'm going to take, let's see, I'm going to take this gas tank STL and bring that in here. So this part is quite different from the last one. And there you see the audio orientation has worked and actually flipped it for me. Not sure I actually want to print it this way. I'm going to think about that. So this might be an instance where you might play around a little bit and say, you know, even though this might be the fastest way, I'm not sure it's the safest way, or I'm not sure it's the way I want my print to come out. But as you can see, this is a really thin part. So a little bit different from the last, and a really curved part. So it's going to require quite a bit of support to think about. I am going to use a 1 millimeter extruder on this, and I'm going to do single extrusion for this part. So, but I'm going to use our Pro HT material because it works really well for single extrusion. I'm not sure if any of you have, you know, printed hands-on with this, but it breaks away from itself really easily. So if you don't want to use dual extrusion, it's a great option. So remember what I said last time, I made, you know, some changes because I was doing a dual extrusion print. And now that I've brought in a new STL and changed machines, it's asking me if I want to discard or keep those changes. And I'm going to say discard because this is a new print, new file. And then I'm actually going to go over and just disable this one altogether since I'm only doing single extrusion. And I'm going to move this forward a little bit. And I'm going to now select my layer height. I'm going to go with a 0.6 for this one. And then I'm actually thinking that I might want to rotate this and flip it the other way. So I am going to take my rotate. Doing that, and then rotating it like so. I'm trying to avoid having, again, any sort of support on that front face. I want all of this to look really good. This is a prototype, for a motorcycle, and it's going to be finished. For example, you're going to want to spray and paint it, and the client's only going to see this outer surface as this is all connecting to something else. So having support on the interior for me, for this example, is totally fine. Keeping this exterior really clean is important. And so I'm going to actually turn off snap rotation for a moment and rotate this a little bit more. And so I think the reason it oriented it in the other position is because sometimes, having a part that doesn't really have anything touching the bed is really risky. I have actually printed this part before, so I have some experience with it. And I have used a raft and used really heavy support along the bottom, and it's printed really well. So I am going to now look at the areas that are red. So obviously this whole edge needs support. This edge is calling for support, but since it's so thin, I'm going to say I don't want it there. So I'm actually going to now go back to my support blocker tool, put it in there like so, and now I'm going to scale that up. But I don't want to uniform scale it this time, so I'm going to turn uniform scale off. I just actually want to make it a bit wider, but not too deep. So just like so, make sure that, it's encompassing all of that red at the top. And that looks good. Okay, so the next thing for this one, I'm going to do a little bit of manual support possibly after I see the preview and see if I think that it's strong enough to hold itself up. The other thing I'm going to do is go to my support. I'm going to make the density, actually I'm going to leave the density as it is. The one thing I do want to change is I want to actually have the support inflate a little bit, because as it's supporting that really thin edge at the bottom, I sort of want it to be a little bit fatter than that edge to sort of hold the edge down. So I'm going to find that setting here among the million support settings that we have available. And here it is. So support horizontal expansion. So right now it's expanded at 1 mil. So essentially, and the great thing is, as I'm sure you've all noticed, when you hover over a setting, it's going to give you a brief explanation of what that setting is, which even I currently find really helpful sometimes, as there are so many setting options within Blade. So right now, that horizontal expansion of the support is 1 mil. I'm going to up it to 2 mil and see how that looks. And now I'm going to close this out, and I'm just going to slice it. And then, as I said, if I feel like I need to add some manual support, to hold this part in place, I will do so. But first, I just want to have a look at what the preview shows us. So as you can see here, there's some areas where it's not, generating support because it's a little bit of a high angle. And these we probably don't need. So we can go back in, delete these support structures here, and maybe add a little bit here. Generally, a support that's this thin and tall isn't always the safest to go with. So I like to have continual support throughout. Fortunately, we have this. But since it's not touching the part until the top, it's not really helping us in terms of keeping the part on the bed. So I am going to add a little bit of manual support here. So I'm going to go back to prepare, have my STL selected, go to manual support, and click on this area here. Where was it? Here it was. And now I'm going to scale this support up. Turn off uniform scaling. Let's see, we might have to bring it all the way down to the bed, but I'm thinking we might also not have to for this one. So let's see how that worked. Are there any questions so far in this part? Okay, let's see. Okay, so I did have an issue with my blade not showing my preview just a moment ago. So let's see. Sorry about that. And the one other thing I want to do actually before I slice this finally is what I had mentioned before is the raft. So generally I don't suggest using rafts, but as you can see here, there's an area called build plate adhesion. So over here, you have the option of a skirt, which I'm sure all you 3D printing people know is the outline around the part just to get the extruder heated and going. We have an option of a brim, which is generally what I always use. So, you know, essentially a skirt, but touching the part, holding the print down on the bed. And then we actually have a raft or none. So generally I don't use a raft because it's quite hard to remove from the part itself as it's very dense. But because this part doesn't really have much touching the bed at all, I'm going to put a raft in place because it'll come off when I'm removing the support along the bottom edge here, and it'll add some extra to the build plate to hold it down and keep it stable while printing. So I'm going to hit raft, and now it's going to, you know, bring up a million layers. I'm going to use the standard settings that come with raft, and I'm going to close this out, and I'm going to hit slice. Let's see, hopefully it'll give us a preview this time. There we go. So now as you can see, there's a nice like chunky element touching the bed, not just support structure. So I think that this is a lot safer of a bet printing a part like this. So any part that's really thin or that doesn't have a lot touching the build plate at all, particularly this part where it's only support touching the build plate, you know, you're going to want something in between those two things to really hold it down on the bed. And the other thing to look at for a part like this is the distance between the support and the part. And I get a lot of questions about this. As you can see here, there's quite a bit of distance in X and Y, but it's almost touching in Z, which is probably good because we want the support to really anchor that part down. Again, though, you can, you know, make it even closer. If we go to the support tab here, you can, you know, close that gap in. You can make the density higher, things like that if you're worried, or if this part, you know, fails or starts moving. Anything like that. So support Z distance is essentially where you would do that. So right now it's at a 0.6 mil, and I'm going to leave it at that for now. And the other thing that I did mention in here that is something to look at on a part this thin is you always want to make sure that you have, or, you know, it's helpful to have 2 loops, I guess, per part. You know, it really secures the part. It allows it to weld together. Part like this that's quite thin, one of the settings that you may have to play around with, which was in that list, is, you know, changing essentially that extrusion width. So although you have a 1 mil, a 1.0 millimeter nozzle, you don't have to extrude at 1.0 millimeter. You know, it can vary a little bit within a certain window. So this actually part looks quite okay. It's doing 2 loops and it's filled in. So not necessarily needed for this part, but I'll show you anyway what I mean. So essentially, if you go under shell, wall thickness is at 2.4, wall count is 2. And if you go under quality, line width is 1.2. So essentially, it's extruding, it's just, you know, measuring the amount of material that's getting pushed through the nozzle at a certain amount of speed. So even though it's a 1 mil nozzle, it's extruding a line width of 1.2. You can see here a little that the lines are overlapping a little bit, so I'm actually going to change that to 1.0. So now that line width has become exactly 1 millimeter. So sometimes you'll see if you have a really thin part, you know, as an example, there might be a little bit of a gap, which we might notice now. Maybe I've made that line width too thin, or there might be a little bit of an overlap. And this is one of the most common things, you know, if you're printing really thin, intricate parts, that you may have to make adjustments to within the, you know, presets that we give you from BigRep. See, so now actually it might have worked better before. So now, now that I've changed it to 1, there is a little gap there and you're seeing this yellow line. So essentially it's doing a gap fill, which adds additional retraction. So not generally something you would want. So it's all about getting it as clean as possible within the loops. So actually, you know, in doing this test, I've realized that 1.2 is my better option. Unless you want, you know, more loops. I'm not sure why you might want that, but you know, there's reasons for everything. So, but for a part like this, yeah, I realized that actually 1.2 is the better option. So I'm going to hit, you know, revert back to 1.2. And then I would reslice that. And there we go. So I think it looks good. Again, I would probably do a little bit more tweaking to the support, but I'm going to move on to do one last STL with you. So I'm going to hit prepare, and I'm going to clear build plate again. And let's see. Maybe we bring in this car cover part, as this one's quite complicated. Are there any other questions so far?
None from my side. Feel free, ask away. You've got the expert here.
So I'm going to switch now to the Pro. So for example, this is a part that actually we may have to cut. So a lot of parts, you know, when they don't fit on the bed, you can have a look at them on the print bed before thinking about where you might want to cut something. For now, since I don't want to bring this into Rhino and cut this with you all, having to watch, I'm going to scale it down a little bit so it fits. And I'm going to go down to, do uniform scaling, 75. Okay. So for this one as well, I'm going to do a single extrusion for now. So I'm going to disable that other extruder. And the other thing to know is that, you know, if you're switching between extruders and you're doing single extrusion, if your part ever looks like this, like is kind of grayed out in a strange way, that probably means you might not have the right extruder selected for your part, your STL itself. So aside from selecting the extruder at the top, you also have to tell it which one you want down here. So generally on the Pro, the ACE is the T1, so I'm actually going to move this to T1. And I'm going to disable that one. Oh, it's not letting me here. Let me scale this down a little more. So I'm going to hit, let's see if this helps. Sorry, I'm going to bring this in one more time. I'm having a little bit of a glitch with the STL. Sorry about that. Okay, so this is actually a part of a car part. So also quite a complicated part to print FDM. I think there is just a little issue with the STL, but I'm gonna move ahead with this anyway. As you can see, generally that gray area is, telling you the amount of space that the STL needs around it on the print bed for it to be successful. A lot of times this sort of allows you, maybe this is a good example to show this. If your STL is not closed, it has an issue where it's not watertight, perhaps there's, a triangle missing, an edge open, you actually will get an error popping up in Blade, which I accidentally X'd out of habit. I'm not sure if any of you saw it, but also as you can see here, this part shouldn't need all of this gray area around this side. So, for example, this STL is probably not completely closed and clean. But since it is in organic form, I do want to work with it to show you something. So I scaled it down a little more than I normally would to allow it to fit on that print bed. So I'm going to go up to auto orientation and run that quickly to see what it gives me for this part. And yeah, so it's actually in the orientation that it is already. So essentially, the reason I think it did that, this is the closest surface to a flat, perpendicular surface that we can place on the bed. And also because this is thin and generally a straight element, printing it up will give us that best surface finish. Again, this is just a prototype, so not super important to have a lot of strength. As I'm sure some of you know that have had experience with 3D printing, a lot of times printing horizontally is stronger, whereas printing vertically will give you a better surface finish as you'll have that clean buildup of lines. As where you do it horizontal, sometimes you do tend to run into issues of having that topographic look. Obviously, all of that can be adjusted, making the resolution higher, orienting things specifically in a way to sort of avoid that. But for this one, yeah, so we're going to orient it like so. So as you can see, all this red area is going to require support structure, but not a ton of support. And most of the support, again, is on the bed. So we might consider wanting to do a raft for this one to hold it down or adding manual supports. But for now, let's see here. I am going to slice this. Yep, we'll use extruder T0. I'm going to do a single extrusion for this one. So I'm going to disable that other extruder. And I'm going to slice for high temp material. So I'm going to discard changes from my last print. Oh, sorry. I'm actually going to do Pro HT. So we'll stick with Pro HT for this one, as the high temp is not available yet. So as you can see, when I select the high temp material here, it actually tells me that it's not yet compatible. So I will switch back to our Pro HT. And I'm going to select a layer height sort of in between. So I'm going to go for a 0.4 layer height for this one and see what that gives me in terms of time. So without making any changes, first I'm going to just have a look and see what it gives me and see how I feel in terms of how successful I think the print's going to be. So a relatively quick print. It is really thin. This is again another one where we have to look at maybe that extrusion width and make sure the part is thick enough and we're getting enough loops in there. So let's have a look at the top. So right now it's only one loop with a really skinny yellow line down the middle. So essentially the gap fill that it's doing. So we want to consider changing that extrusion width or maybe using a smaller print head. But otherwise the print looks really good. It does have all of this support here. It has a lot of support here, which is going to help holding that print down on the bed. Again, we might want to add a little extra support here to hold the part down, since this area has a lot less support and is the larger area of the build. You know, sometimes when there's print like that, it tends to pull it a little bit up off the bed. But, you know, we could try it as so and see how it works first. Or we could, you know, tilt it a little bit. There's different options that one could try. But I think I'm concerned a little bit about this. So what I would do, since, you know, this, I'm going to actually switch over to the 1 briefly for this part because I want to slice with that 0.6 nozzle. So I'm going to switch over to the 1. I'm going to go to the power extruder 0.6 nozzle. I'm going to hit discard changes, and I'm going to look at that line width here. So now we have a line width of 0.8 instead of the 1.2 since we switched nozzle sizes. So I'm going to have a look and see if we were able to now get 2 loops in there with this thin part. Otherwise, there are options. You know, if this is just a one-off prototype, there are options to also, which I can show in a moment, expand your part horizontally. So essentially make your STL thicker within blade itself. So now obviously it takes a lot longer. I have it at a 0.2 layer height, which is extremely high resolution. Obviously we can raise that up, but generally what I'm concerned about is seeing those loops and seeing if it's able to do 2 now with a smaller nozzle, which it is. So now we have what I had mentioned, you know, those two full loops within the model, which are going to make the part a lot stronger and print a lot cleaner. And so we're able to do that by switching down to the 0.6 and using a 0.8 line extrusion. Are there any questions? I know we're down to about 10 minutes, so there are a few other things I can touch upon that I was going to say for the advanced training, but I just want to make sure there's no questions so far in what we've talked about or on any of the STLs that I sent. Okay. So I'm going to go back to prepare and delete. So what I'm going to do now then is just show you the batch printing options since we have the time. So I'm going to bring in the sample mechanical part, which is a little bit smaller. I'm actually going to switch to the studio for now. So unfortunately, when doing, so there's 2 options, as you know. You can do sequential printing and then batch printing. So you can, you know, fill up the bed as much as you can to allow for a print by print. So doing one whole print, moving over, then doing the next. Obviously, with this option, you're going to be able to print a lot less parts on the print bed as you need a lot of space around for the gantry to move and not crash the finished part. The other option is to, you know, fill the entire print bed up and print all at the same time. So essentially it would print, you know, the first layer of each part, second layer of each part. There's really specific reasons to do one or the other. Obviously, when you're printing all the parts at once, it's going to take a lot longer. as it has to move and do so many retractions. But say you want to print a lot of small parts over the weekend or overnight and you want to come into your office the next day and have them finished, that's an option to do so. Obviously, if the parts are really big, and if the parts are, all different, you can't do that sort of option, but I'll show both. So, and the one thing to know is that when you do sequential, so 1x1 printing, you can only do it currently using single extrusion. It is not able to be done with dual extrusion yet. So I'm going to show you that option first, and in order to do that, I need to disable one of my extruders. So let's see here, going to go to my support, switch that back. For some reason, sorry, it's not letting me disable that extruder. Let me just. So those two options that I mentioned are both going to be under extension. So if you have your, object, your small STL in, you can hit either populate build plate completely or populate build plate for sequential printing. And then the top option is used when you have multiple STLs that you want to print 1x1. So this might take a minute because my computer isn't super fast, but if you hit populate build plate completely, now you'll see it's taken that STL, given it all the space it needs, and is filled in that build plate. So build plate, and it tells you at the bottom, it says build plate was able to fill with 24 objects, and that's the maximum that you can do, leaving some space in between to allow for the gantry to move around. I'm going to hit undo quickly, and then I'm going to select that and do the other option, which is populate build plate for sequential printing. So now, since the studio has the gantry moving in the Y direction, it's going to, it'll print this hole. So the gantry goes across like this on the studio. So that's why they're sort of oriented this way. So it'll print this whole one, it'll move on, print this whole one, and it's left enough space in between so that that gantry will not crash. This is a little risky. Personally, I might, remove just one of these, but if you wanted, maximum capacity, this is the option to do so. And then, the last option, which I show, I'm going to hit undo once more, and I'm actually going to bring in I'll bring back in that intake manifold quickly. And I'm going to just you can actually multiply your model by right-clicking it, and I'm going to hit multiply select model. I'm going to say I want one extra copy. So in total, we'll have 3 parts, 2 of this one and 1 of this one. And then you're going to select all your STLs, and then you'll go to arrange objects for mixed mode. So essentially that means sequential printing as well, but it's when you're doing different models. So, it's placed 1, 2, and then 3. Are there any questions about that? Okay, great. So I'm going to slice this just so we can have a look quickly at what that means. Sorry for the slow slicing. There we go. So now we have our 3 parts. So for some reason, I'm sorry, my blade is being ran into a little bit of an issue. I actually restarted it, but it didn't allow me to deselect the second extruder. So it's going to slice them all at the same time. Like I had mentioned, you have to disable your second extruder for it to do it sequentially. So if I had, in fact, disabled, it would print, this one last, this one, then this one. So you would have a slightly different outcome than you're seeing now on my screen. Here we go. Now it allowed me to disable. So let me show you now what that means. Let's see here.
do have one question here too. It says, can you print the one next to the other one at the same time and then the other two, like a mix between sequential and batch printing?
I think that gets a little tricky. I'm trying to think if there's some sort of override you could do to do something like that.
Like
I
it says
know-
like batches of 2 pieces sequentially.
Yeah, so essentially, I know if you have, you know, a lot of parts, it'll actually do it that way for you. So it, you know, if I had filled this up in a way, we can actually try it and see if I can show it to you. Let me just preview this really quickly. And we can try to touch upon that in the last few minutes. So now you can see, since I disabled that extruder, it's doing 1, 1, 1. So I think what you're asking is, could I move this one here and have these 2 print and then print that one? I'm assuming that's what your question is. I'm actually not sure if I just move it, if it do that. We can give it a shot. I do know that if you have, you know, like 8 of these and 1 of these, it'll orient it in a way that it'll print, you know, the same ones in the row, and it'll do, you know, 1, 2, 3, 1, 2, 3, 1, 2, 3, and then the last one. I'm just not sure if you don't have enough to fill that build plate up, if it'll do it that way. But let's have a look. Yes, so in fact, you are able to do that manually. So it just, I think the steps you have to take are first selecting all 3 STLs and running that batch printing arrange for mixed mode, and then you can go in and manually move them. So if what you were asking was to print these 2 at the same time and then this one, we were able to achieve that by just moving these next to each other. So hopefully I answered your question.
I think so. Yes, he says thank you.
Are there any other questions? I know we're almost out of time.
Just looking, scrolling through, make sure I didn't miss any here.
Also, obviously, anyone feel free to reach out if you have, you know, STLs that you would like to cover or talk about, that you're running into issues with. Me and my team are always here. So we're happy to do any sort of one-on-one helping with the STLs with you.
Just a short question, maybe.
Sure.
I'm really interested in sequential printing. It's really important for us. And so I'm wondering, when will be the support for the dual extrusion be possible? Is this year or maybe next year, or?
That is a question I'll have to ask software. I'm assuming it'll be this year, but when this year, I'm not sure. But I know we're going to follow up with you in regards to another question you had brought up earlier, so I can take note to see if I can get an ETA and what quarter that'll be available.
Okay, thank you.
Yeah, of course.
All right, well, we are over by 1 minute. But yes, so Maggie is hosting an advanced training on Thursday, the 28th. So you should have the link to register for that if you haven't already, to continue the blade training. But like she mentioned, if you have questions or anything, please reach out. The Europe team and the North America team are here to help you. And that, thanks, Maggie. And thank all of you for joining us. And we'll be in touch soon. Thanks and have a great day.
Great, have a nice day.